That small gray bug that rolls into a ball when you touch it is not a pest. It is a soil remediation system that has been running in your garden every night for decades. Kill it, and your soil starts dying within one season. What it actually is. The pill bug is not an insect. It is a crustacean. The only crustacean species on Earth that has fully adapted to terrestrial life without any dependence on aquatic habitat. Its closest living relatives are lobsters, crabs, and shrimp. It breathes through primitive gills that require constant moisture, which is why it lives in damp soil and emerges at night when surface humidity rises. It has been living in soil ecosystems for 300 million years. The garden pest your exterminator sprays on a routine perimeter treatment is 300 million years older than the chemical being used against it. Soil cleaning mechanism. Pill bugs feed on decomposing organic matter exclusively. Dead leaves, rotting wood, fungal growth, and decaying plant material are their primary food sources. As they consume that material, they fragment it into smaller particles that soil bacteria can process more efficiently. That fragmentation accelerates the decomposition cycle and releases nutrients back into the soil in plant-accessible form. A single pill bug colony processing the leaf litter in a standard residential garden bed accelerates nutrient cycling by a measurable factor compared to gardens without pill bug populations. The nutrients locked inside dead plant material reach your living plants weeks faster because pill bugs broke the organic matter down first. Heavy metal absorption. Pill bugs perform a soil function that no garden product on the market replicates. They absorb heavy metals from contaminated soil directly into their bodies during digestion. Lead, cadmium, copper, arsenic, and zinc, present in soil from decades of pesticide use, automotive pollution, old paint chips, and treated lumber leaching, all concentrate inside pill bug tissue rather than remaining bioavailable in the soil where plant roots absorb them. Research published in the journal Cell Biology and Toxicology documented this mechanism and confirmed that pill bug populations in contaminated urban soils measurably reduce heavy metal bioavailability across the soil profile they inhabit. They are performing free phytoremediation, the same process environmental remediation companies charge between $500 and $5,000 per treatment to achieve using chemical soil amendments and extraction methods. Calcium recycling. Pill bugs are the primary calcium recycling mechanism in most temperate soil ecosystems. Their exoskeleton contains high concentrations of calcium carbonate, the same compound that regulates soil pH and provides the calcium that plants require for cell wall construction and root development. When a pill bug dies in the soil, its exoskeleton breaks down and releases that calcium directly into the surrounding soil profile. A healthy pill bug population, cycling through normal lifespans, continuously deposits calcium into your garden soil without any external input. Calcium deficiency in garden soil produces blossom end rot in tomatoes, tip burn in lettuce, and stunted root development across most vegetable species. Gardeners spend between $15 and $40 per season on calcium soil amendments to address deficiencies that a healthy pill bug population prevents from developing in the first place. The pill bug is a calcium supplement that manufactures and delivers itself. Fungal network protection. Garden soil contains a fungal network called mycorrhizae that connects plant root systems and facilitates nutrient transfer between plants across the entire garden bed. That network is fragile. Soil compaction, synthetic fertilizer overuse, and pesticide application all damage it. Pill bugs protect it through their feeding behavior. They preferentially consume harmful fungal species that compete with mycorrhizal networks for soil space. Pathogenic fungi, including Fusarium, Pythium, and Rhizoctonia, are consumed by pill bugs as part of their normal diet. Those are the same fungal species that cause root rot, damping off, and crown rot in garden plants. A pill bug population actively suppressing those pathogens is performing the same function as a biological fungicide application. Commercial biological fungicide products containing beneficial bacterial strains that compete with pathogenic fungi run between $20 and $60 per application and require reapplication every 2 to 4 weeks throughout the growing season. The pill bug provides continuous pathogenic fungal suppression at zero cost from the moment soil temperature rises above 50 degrees in spring. Soil aeration. Pill bugs move through soil constantly during their nighttime foraging activity. That movement creates microchannels in the soil profile that improve water infiltration, oxygen penetration, and root expansion capacity. Compacted soil without biological activity forces plant roots to navigate a dense, airless medium that restricts growth and reduces nutrient uptake efficiency. The microchanneling pill bugs create through normal movement is not equivalent to mechanical aeration, but it is continuous. A lawn aeration service creates channels once per season at a cost of between $75 and $200 depending on yard size. The soil those channels pass through compacts again within weeks as foot traffic and rainfall consolidate the loosened material. Pill bug movement creates new microchannels every night throughout the active season. The cumulative aeration effect across a full growing season from an established pill bug population exceeds what a single mechanical aeration achieves because it is applied continuously rather than once. A compacted garden bed without biological activity is a bed where plant roots hit resistance at every growth point. The pill bug removes that resistance nightly without a machine, a service call, or a seasonal fee. What happens when you kill them? A standard perimeter pesticide treatment applied by a pest control company reaches garden beds along foundation walls, under deck edges, and along fence lines. Those are the exact locations where pill bug populations are highest because moisture and organic matter concentrate there. The pyrethroid applied during a routine treatment kills pill bugs on contact and leaves residual active for 3 to 4 weeks. A second treatment 3 weeks later extends the kill period through most of the active growing season. The soil remediation system stops the night of the first treatment. Organic matter in the garden bed stops fragmenting at the biological rate. Heavy metal absorption from the soil profile stops. Calcium recycling from exoskeleton decomposition stops. Pathogenic fungal suppression stops. Soil microchanneling stops. None of these functions are replaced by the pyrethroid that eliminated the pill bug population. The chemical kills the pest the technician identified. It does not perform any of the soil services the pest was providing. Plant decline following routine perimeter pesticide treatment is well documented in organic gardening research. Gardeners who switch from chemical to biological pest management consistently report improved plant health within 1 to 2 growing seasons as soil biology rebuilds. The connection between the spray and the plant decline is never made explicit on the pest control invoice. Industry misidentification. Pill bugs appear on pest control inspection reports under the category of moisture pests, alongside silverfish, springtails, and fungus gnats. That classification is technically accurate in one narrow sense. Pill bugs require moisture to survive, and their presence in high numbers inside a structure indicates a moisture problem in the adjacent soil or foundation. The industry response to that accurate observation is chemically incorrect. The recommended treatment is a perimeter spray targeting the pill bug population as the problem, rather than addressing the moisture condition that brought them to the surface in higher than normal numbers. Pill bugs do not damage structures. They do not damage living plants. They do not contaminate food. They do not bite. They do not transmit disease. The only context in which pill bugs damage living plant material is when their preferred food source, decomposing organic matter, is absent from the soil, and population density forces them toward living seedling stems as an alternative food source. That seedling damage occurs exclusively in heavily tilled, organically depleted soil, where the biological decomposition system has already broken down. The pill bug is not causing the problem in that scenario. It is the symptom of a soil ecosystem that lost its organic matter base. Adding a perimeter spray to that situation removes the remaining biological activity from already depleted soil and accelerates the decline the gardener was trying to stop. Pest companies charge between $80 and $150 for that treatment. The garden gets worse. The follow-up visit is already scheduled. Plant health math. Here is what an established pill bug population is worth to a standard residential garden across one growing season. Nutrient cycling acceleration through organic matter fragmentation reduces the amount of supplemental fertilizer required to maintain plant health. Gardeners with active soil biology consistently apply 30 to 50% less supplemental fertilizer than gardeners working in biologically depleted soil. At an average seasonal fertilizer spend of $40 to $80 for a standard garden bed, that represents $20 to $40 in direct input savings per season from accelerated decomposition alone. Heavy metal bioavailability reduction protects plant root systems from toxic uptake that stunts growth and reduces yield in vegetable gardens. Environmental remediation of heavy metal contaminated residential soil through professional soil amendment and extraction services runs between $500 and $5,000 per treatment, depending on contamination level and affected area. The pill bug provides continuous passive remediation at zero cost as long as the population remains intact. Calcium recycling from exoskeleton decomposition reduces or eliminates the need for supplemental calcium amendments that prevent blossom end rot and tip burn across common vegetable species. A seasonal calcium amendment program for a standard vegetable garden runs between $15 and $40 per season. Pathogenic fungal suppression reduces or eliminates crop losses from root rot, damping off, and crown rot that affect between 10 and 30% of vegetable garden yield in biologically depleted soil without natural fungal predation. Added together, one healthy pill bug colony, operating undisturbed through a full growing season, provides between $575 and $5,120 in measurable garden input savings and plant protection value. The perimeter spray that eliminates that colony costs between $80 and $150 and provides no replacement for any of the biological services it destroys. That is the invoice the pest control industry never shows you when they treat your foundation line in April. That is the complete picture. A 300-million-year-old crustacean running a free soil remediation service in your garden every night. Absorbing heavy metals, recycling calcium, suppressing pathogenic fungi, aerating the soil profile, fragmenting organic matter into plant-available nutrients. All of it stopping the night a routine perimeter treatment reaches your garden bed. Drop a comment and tell me what you used to do when you found pill bugs in your garden. I read every one, and the answer is almost always either stomped them or sprayed them. If you know somebody whose garden plants have been declining for no obvious reason, and they have been getting regular pest treatments, send them this video. The reason is probably on their invoice.